Hi guys, as you can see, I'm back again with another video, and today I'm going to show you how to apply the fundamentals that I taught you in the first two videos. If you haven't watched those videos, please go ahead and watch those videos first. Okay, let's go to the question. The question is saying a battery of EMF 2.4 volts and negligible internal resistance. So negligible internal resistance, we're going to ignore the internal resistance, is connected in a circuit as shown below. A current of 2 amps registers on the ammeter A1. So I must correct that. This in the errata, it was changed to 0.8 amps. So our first question says that state the Ohm's law in words. So the Ohm's law states that the potential difference across a resistor is directly proportional to the current strength through the resistor, provided the temperature is constant. Let me write it down. Now 4.2. In 4.2, they're saying calculate the effective resistance. So you must know the effective resistance is the same as the total resistance. So now to calculate the total resistance here, we must have obviously the total current, the total voltage, or we can actually just simply add all the resistors, right? So obviously, as you can see here, we do have the total current here. This is our total current and this is our total voltage. So we can use those to actually calculate the total current. So that's what we're going to do. So our total current is equal to total voltage over the total resistance. Now substituting in the equation is going to be 0.8 is equal to the total voltage is 2.4 divided by the total resistance. This will give us a total resistance equal to 3 ohms. Right, another way that we can calculate is by simply adding all these resistors together, and we must notice that these ones are in parallel. However, those ones in parallel are in series with this one, so that means we can actually calculate the total resistance first of those ones in parallel and then add it to that. So that's what we're going to do and see if we get the same answer. So it's going to be, let me just change the color here. Ones in parallel first is going to be 1 over Rp is equal to 1 over R1 plus 1 over R2. Okay, substituting, we're going to get 1 over Rp is equal to 1 over 3 plus 1 over 6, which means our Rp is going to be equal to 2. Okay, so now we're going to add, because those ones gave us 2 ohms, that means we're going to add that to that 1 ohm to get the total resistance. So our Rt is going to be equal to R2 ohms plus R1 ohm. This is equal to 2 plus 1, which is equal to 3 ohms. That's our total resistance of the whole circuit. As you can see, this is exactly the same as the one that you got on top there. Okay, so moving on to the next question. Question 4.31 says calculate the reading on the voltmeter. So this is our voltmeter here, and obviously for us to calculate we must understand what's going on in the circuit, and you can see this voltmeter is actually connected to the resistors that are connected in parallel. That means if ever we want to calculate the voltage across these two resistors, we must use information on both the resistors, or we can actually use one of the resistors, because we know that when resistors are connected in parallel, the voltage across them is going to be the same. In other words, the voltage here is the same as the voltage across the 6 ohm and the 3 ohm. So looking at our circuit, we can see that the current that is going to be flowing through the circuit, the total current, is also the same current that is going to be distributed amongst those two resistors, and hence if we can actually use the total of this resistance, we can use the total current that is passing through both resistors to calculate the voltage here, which is what we are going to do. So it's going to be 4.31 using the Ohm's law. Current is equal to voltage over resistance. So this is resistance across the 3 and the 6 ohm resistors, right? In other words, the total resistance of those resistors in parallel. And remember, we did calculate it. However, I'm just going to calculate it again. So it's going to be 1 over Rp is equal to 1 over 3 plus 1 over 6, and then Rp will be equal to, so that means we can actually substitute the current. Remember, we say this 0.8 ohms is the one that is going to be distributed amongst those two resistors, and hence that means it's the same amount of current that we can use to calculate the voltage there. So it's going to be 0.8 is equal to the voltage, the one that we want to find, and the resistor of that resistance is 2. Then we find our voltage here is going to be equal to 1.6 volts. Another way that we can actually calculate this is by using this information. We know that Vt is equal to V1 plus V2, where this will be our V1, and then this, if I put a voltmeter here, this will be our V2, because these in parallel are connected in series with this one. So resistors that are connected in series are voltage dividers. In other words, this 2.4 volts is going to be divided amongst the V1 and V2. So using this information, because we know that this 0.8 amps are the ones that are going to pass through the 1 ohm resistor, we can calculate V2. So to calculate V2, is going to be current is equal to V2 over R. Then the current is 0.8, which is equal to V2 over the resistance is 1. So our V2 is actually equal to 0.8 volts. And then using this equation, we know that the total voltage is 2.4, which is equal to V1, that's the one we want to find, plus V2. V2 we just calculated it 0.8, and hence if we rearrange to calculate for V1, we are going to get V1 is equal to 2.4 minus 0.8, which will give us 1.6 volts. That will be our answer, exactly the same as the one we got when we're calculating here. Okay, now let's move on to question 4.32. They're saying we should calculate the ammeter reading at A2. All right, so this is A2 here. So obviously here, what you should understand is that you must make sure that you use the information on the 6 ohm resistor and the current that is passing through the 6 ohm resistor and the voltage across the 6 ohm resistor, of which the voltage across the 6 ohm resistor, remember, is the one that we just calculated here, which is our voltage, and V1 in this case, and then the resistance is 6, so we can actually calculate A2 here using that information. So again, current is equal to voltage over resistance. Our current is the one that we want to find, is equal to the voltage. The voltage, we calculated it, is 1.6 over the resistance. The resistance is 6 ohms, hence our current is going to be equal to 0.27 amps. Then we are done with this question. Moving on to the next question. Now looking at this question, they're saying the 3 ohm resistor is now replaced with a 6 ohm resistor. So that means this is no longer 3, it's now 6 ohms, the same as this one. And then they say, how will this affect each of the following? Increase, decrease, or remain the same? The reading on ammeter A1 here, that means how will it affect the total current? We must explain our answer. So to attempt this question, what we're going to do is we're going to see how increasing the resistance here have affected the total resistance of the circuit. So the way that we can actually do it is by calculation, very quick calculation. So 4.5.1, the total resistance is going to be, we calculate the ones in parallel first. Our RP is going to be equal to 3 ohms, and then the total resistance of the circuit is going to be equal to 3 ohms plus 1 ohm. We can see we are going to get 4 ohms. And remember here, when we're calculating the total resistance of the circuit, that time the total resistance was actually 3 here. The total resistance was 3, and now the total resistance is 4. So the total resistance of the circuit actually increased. Since the total resistance of the circuit actually increased, this will lead to a decrease in the current. In other words, the reading on A2 is going to decrease. Why is it going to decrease? Because we know that current is directly proportional to the potential difference and inversely proportional to the resistance. As you can see, these are inversely proportional. So since the resistance increased, then the current will decrease. That's how you're going to explain it. Okay, now moving on to the last question, 4.5.2. So now they're saying what is going to happen to the reading on A2 here. So in this question, the best way that I saw fit was actually to calculate the current that is going to be produced and see how it compares to the one that we calculated previously when the resistance here was 3. So that's what I just did. So I'm just going to quickly calculate. Though it's 1 mark here, you can see maybe there's a easier way to determine it, but then I'm just gonna do the calculation so that it becomes easy for you to understand. So now, so current is equal to voltage over resistance, the total resistance now, so the total voltage. So now the current is the one that we want to find, is going to be equal to voltage is still 2.4. However, the total current resistance is now 4, which means our total current is now 0.6 amps. So that means instead of being 0.8, it's now 0.6. Thus 0.6 amps is going to come in this direction, going to be split equally because this is 6 ohms, and hence that means it's going to be 0.3 here and 0.3 the other direction. And then if you can compare this to the one that we previously calculated when the resistor was 3 ohms here, you will see that it was actually here 0.27. When the resistor was 3 amps, it was 0.27 amps. So now is 0.3, so the current actually increased. Here you're just going to simply write it increases. There's no need for explanation, so that will be your final answer. Right, guys, if you enjoyed this, please like, subscribe, and leave some comments.